In this video, we will review how to create singular summaries of continuous variables using an AD. Usually, when you have an analysis definition that you attach to a cohort, you get a single value, like a sodium, like a creatinine, like a hematocrit, and you use wide view for that. Sometimes you want to get all the sodiums for a time period, or all the hematocrits for a time period, and you use long view for that, and that collects all the hematocrits that belong to that patient over that interval of time. But sometimes what you want is you want a summary measure. You want to know the average hemoglobin A1C, or you want to know the minimum hemoglobin A1C, or the maximum hemoglobin A1C. Or if you have something whose sum makes sense, you want the sum of all dollars spent. For this, you need this new attribute of continuous variables, the attributes of minimum, maximum, average, standard deviation, sum. In this exercise, I will show you how to achieve this. As you see in front of you, we have a study. And that study is made up of a group of patients who were found to have a hemoglobin A1C in 2010. Now, we are going to add a method, and this method is going to be a list method, and we're going to call it hemoglobin A1C report. I'm going to add it. We have all these different variables on the original cohort, and I'm going to get rid of them all because I really don't care to see them. And what I want to do now is I want to use the advanced method, and I want to select something called hemoglobin A1C. Let's take a look at this analysis definition and see what it looks like. As you can see, it is an all, and it's all the hemoglobin A1Cs 0 to 365 days after the collection date. So it will capture the original hemoglobin A1C, because it starts at 0, and all the next hemoglobin A1Cs over the ensuing 365 days. And since both lines have all, this is going to give you not a singularity, it's going to give you all the values. Now, as you learned in your course, if you have a singularity, such as earliest, latest, you can use wide view. But if you want to show all, normally you have to use long view, so that each row has its own lab value, repeated over and over again. But in fact, what I really want here is I want the average number of hemoglobin A1Cs. I want the highest or the lowest, and I want the count. Each of those are summary measures, are singularities in their own right. So I can keep the wide view because I'm about to ask for singularities, but I must make sure that I have nothing that will drive the multiple instances of outcomes. So for example, the event date and the group numeric lab both have to go because they are unique to each laboratory value. And now what I want to do is I want to bring over count, as I've done before. This will tell me for each patient the number of hemoglobin A1Cs I have. I'm going to bring over sum. Notice it's under lab test value. Sum, average, standard deviation, min, max, and just for the sake of completeness, I'm going to bring over value. And since all the outcome measures are singularities, I can put this in wide view. Count, sum, average, standard deviation, min, max. Not value, actually. We have to get rid of value because each hemoglobin A1C is its own value, and that would generate a huge number of columns or require a long view. So I'm going to get rid of value, and now I'm left with count, sum, average, standard deviation, min, and max. And then I just run it. I've already run this before, so I'll go back to this. I've already run this before, and now I can look at the results. And here are the results. The maximum value, the minimum value, the standard deviation, the average value, the sum of all those, and I seem to have forgotten the count. And now in one spreadsheet that you can export, you can get this summary for each patient, the average, standard deviation, min, max, and count.